This is practice A for section 6.4. Is there enough information to determine whether the triangles are similar? If so, write a similarity statement and find the scale factor. So we have two pairs of sides and an angle that's given. Now the only issue with this is that these angles that are congruent aren't included. That's a major issue. So it's possible that they could be similar. We just can't say for sure that they are. In fact, could we say that they're not? Well, 9 to 10. Notice how this touches the 72-degree angle, so does this. 9 to 10 is not the same ratio as 14 to 15. Okay, so they're definitely not similar in this example. We don't have proportional sides. In this next example, this triangle and this triangle have that shared angle. So I'm going to redraw the two triangles. So you have a pair of congruent angles that's in between these sides. This is 15, this is 20. This is 27, be careful. And this is 36. 15 to 27, is that the same thing as 20 to 36? Let's see. They both equal 5/9. So yes, these are similar. So we're going to write a similarity statement here. We'll call this triangle DCG. It's similar to this triangle. We'll call it ECF. So they're similar by side angle side, and the scale factor is, what did we say was 5/9? Next section, are the triangles similar? If so, write the similarity and state the similarity and the postulate or theorem that justifies your answer. Let's look at number 13. You have this right angle here. This is a straight angle, so this is also a right angle. So what happens is, again, I could redraw these triangles to help. We have this length on here. We don't know what it is, but let's pretend it's x. This length is going to be twice as big. So if that's x, that's 2x. You don't know two side lengths. So it looks like the side lengths over here, at least this one, is twice as large. That doesn't mean these ones are twice as large, but it doesn't mean that they're not either. So this is not enough info. Number 14, both of these triangles are isosceles. So if this is 9, so is that. If this is 6, so is that. Now you can check your ratios. 6 to 9 is the same thing as 6 to 9. That's 2/3. Is 4 to 6 2/3? Definitely. So state the similarity and the postulate or theorem. I think they mean similarity statement. Okay, so it's an isosceles triangle, so again you have some flexibility. Triangle ABC is similar to, I started at the vertex angle, triangle XYZ by side, side, side. And the scale factor we said was, well, big to little would be 3/2. Number 15, both triangles are isosceles, and the vertex angle in both of these triangles are 30. So that means you have 150 degrees left to use between those two angles. So both those angles are 75 degrees. Same thing with this one. These are both 75 as well. So they're similar by angle. So we'll call it triangle NMO, similar to triangle QPR. Again, you have some flexibility there because they're both isosceles. Now, what's the scale factor? Well, you can't determine that from the angles, but you could from the sides. Okay, so we do have one pair of corresponding sides. 6 to 4 is the same thing as 3 to 2.